let's first start with going over the homework questions. You guys had trouble on 19, so you could take a rectangle, right, and surround. There we go. Surround it, so let's make that. Okay. Purple.
I like purple.
It's kind of lavender, huh?
And there's purple in
One right next to it.
Okay, is that purple?
No.
No,
That's
the
red.
one that's often right next.
That's green.
No,
That's the
the-
That?
no.
Yeah.
That's blue.
That looks like purple though.
It looks purple.
Lavender. Purple. I was right. Okay. Okay, so we're gonna surround it. That's really good teacher behavior. Sorry.
I was right.
You know, I was just doing that, right? Okay.
It's okay. We all
So we're surrounding it, and when we surround it, the purple rectangle 16 units. Yep.
Yeah.
And then you can see that, like, this right triangle here has an area of 6, because, do you see that?
Oh, yeah, base times height.
Base times height, sure. You do base times height divided by 2. Does everybody see that?
Yes.
Okay, so 6, and similarly, this would also have an area of 6, right?
Wait,
Because this is 3
5, 4.
by 4, right? So half of that is 6, and this is a half, right? So this is where you can't really chop the inside up very well. You have to use the surround. So we're going to do 16 take away 12 and then take away another half, right? So that's 4, take away a half. That's 3.5 square units. And any questions on that? Okay. So the next one, similar approach, we're going to surround. We still have purple? No?
Green.
And green.
Oh,
Bright green.
Yeah.
Okay.
Yeah.
All right. So green gives us this, and that area of that rectangle is what?
Like
4 by 3, right? So it's 12, right? So start with 12. Okay, Jill. Then what? Hey, thanks.
No. Well, there's 3 triangles.
The 3 triangles. So what's the area of this one? No.
It's 2.
It is 2. Because it's a 2 by 2, right? 2 times 2 is 4. Half of 4 is 2. And then how about this one, Joe?
Oh, I 3.
3. Good. Quinn, what about this one?
Which one?
The only a triangle that's left.
Well, the
1 by 4, right?
it's yeah. So because the first little box and the last little box go together to make one, and the second and the
So
third go together to make one, and that's good.
you're true. You know, you're making that a lot of work, because if you just think about it, that triangle that's white is just half of this rectangle,
Oh yeah, it's just
right? Try to think that way because it's quicker. So just think this rectangle here has an area of 4, doesn't it?
yes.
And then the triangle is just half, right? So this must be 2 and that must be 2, so this is 2. Does that make sense?
Wait, but problem, you overcut the 3 there.
But I'm only interested in the white, right? So I'm looking at that size rectangle. That's why I moved it out of the picture. And that's why drawing all over the picture sometimes makes the situation less helpful. So I'm really going to do 12 take away 3, take away 2, take away 2.
And you get a magical whopping 5.
That's a great build-up, right? 5 square units, right? So far, so good?
Yes.
Okay. So, same thing, we gotta surround. How about teal? Darker teal. Okay, so we're gonna go right here. Surrounding it? Oh, the reason I did that is so I knew I went down far. I don't know why I did it. Just is the way my brain works, I guess. So what's the area of that rectangle, someone?
4 by 4. I know.
4 by 3, right?
Yeah, that's what I meant.
12.
Yeah, so 12.
So 12, so this triangle right here?
You could do this times this.
You could, because it's a right triangle, right?
Yeah. 2 times 3.
3 units. You guys all agree with that?
Yes.
Okay, Molly, how about this little triangle down here? 1. Okay, and then, Zaya, how about this triangle right here? Right? And this is 1, and what about this, Grace? A half, right? So if you add all the holes up, you have 3, 4, 5, 6. So 12 take away 6, and then take away an additional half.
And you get another magical whopping 5.5.
5.5, right, square units. Okay? How we doing? Good? One more rectangle? How about
Black.
black?
Red.
Purple.
Black's boring. Okay.
Red is
Uh-oh, it's full.
Oh, you didn't get the real color.
Oh, I did. I picked red as the fill color. No fill. So we want
That's
the
the
line
line
color to be
color.
red.
Fill color to be white.
But if the fill color is white, then it will.
It's gonna block it though. Maybe. It's see-through. Yeah, see? Ah,
How do we do not like that?
yeah, let's just make it transparent.
What's behind the square?
You can't really see the red.
The world will never know.
Alright, so that didn't work very well. It's not that smart because it won't let me unfill it. I have to go like the long route to unfill. No fill. Okay,
Now you can make it.
Now you
the
gotta
red,
make
now you
it.
can't see the red.
make the
Really
red.
bad.
Make the red not see through.
That's right.
Yeah.
So you have to go to fill effects.
Oh my goodness, this is a lot of work for a silly problem.
We could have
Okay,
just like
there.
took it away and then made a new square.
That's good. That was a lot of work. Not sure that was worth it. Okay, Emma, what's the area of the whole shape, the red? Good. So it's 16, and then, like, what are these triangles, Emma? 0.5s, right? Halves. 0.5, same
Just
thing.
put them all up, you got 3.
Right, so if I just looked at all of these first,
I know.
then
Well,
what's this
I
one?
got
one more.
through it.
You got 2 more.
I saw 2
Oh,
more.
it's 1.
That's 1.
Emma, this is 1. What's this? 1. Oh,
3.
2 right here, right?
Oh,
And then another,
It's a lot of halves.
so the whole area was 3, right? So count your halves, right? So we have 1 half, so that's a whole, 1, 2, 3 and a half, right? Plus the 4 holes. Do you see that?
Plus 4. Yeah.
So we're really taking away
5.
7.5, right?
I
So
can't count.
I know this one. It's 8.5.
8.5, as Joe would say, 8.5 square centimeters. Okay? Does that help? Okay. So, next thing. So you need that skill to do today's work. Find the area of each square. Of course, the beginning ones are kind of boring. There's not like much to it. Carrie, what'd you get for the area of this?
9.
So 9 square units, right? And keep going, Carrie.
4.
4 square units. And this one?
36.
Okay, 36. So with those 3 simple rectangles, how long is each side of this, Evan?
Each side of that is
3, right? Just from the picture, you can see it's 3 by 3, right? And this one, Evan?
2.
2 by 2. And this one?
6 by 6.
6 by 6.
Are you counting or are you just knowing?
I looked at my answer.
Okay, so do you guys, when you see that, do you have to count to do that or you just know it?
Sometimes
I
no,
count.
I
A
mostly.
little bit of both, right?
Yeah.
So you know, you actually will just know this if you understand the relationship. So, like, isn't 3 times 3 9?
Yes.
Yeah.
So,
Two.
and 2 times 2 is 4. So 6 times 6 is 36, right?
Yeah.
So whenever you have a square, you have to think about what number times itself, yeah, equals that area. So for example, if I just do some, I'm just going to clone this page here. Well, actually, we just use the grid paper here. Okay, so if I just had a square, right, any square, and I was telling you guys what the area was, or you wanted to find one thing like the area, it would be like a pain to count the whole area. So I would just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I know the area is 121 square units, or in this case, the units are centimeters. Okay? Because I know it's 11 by 11. Does that make sense?
Yeah.
So if I didn't have the 11 and I just had the area, I'm looking for what number times itself is equal to 121.
So basically 121 is
I don't understand.
And that's called the square root, right? So if I put another square here,
How do you figure out a square root?
we're going to work on that.
Yeah.
So if this is 25, this has to be
5 times 5.
5 by 5. Does that make sense? So what we say is the square root symbol, we read this as the square root of 25, that's equal to 5. And the way it ties into the picture is the square root of a number is basically how long the side of one square would be that has that area. So like if I asked you for the square root of 49, I'm thinking what number times itself
7.
is 49 and it's 7. So on my grid paper, if I took my square and I went 7 by 7,
So how did I figure out that was it's something with the
yeah,
like
so when it's
5.
not easy, it's going to tie in. So if you look, 1, 2, 3, 4, 5, 6, 7, right? This is 7, 1, 2, 3, 4, 5, 6, 7. That's 7. We know from 5th and 6th grade math, the area is length times width, right? So we say the square root of 49 is equal to 7, and this is the area of a square, and that's the length of the side. And that's what the square root of a number is. It's the length of a side of a square with the given area. Does that make sense?
It's basically 9.
So sometimes we can't get an integer for a square root. So going back to this sheet here, we run into some problems. So what was your area here, Quinn?
It was 12.
So we would have had to, first of all, surround it, right? With with a rectangle, right? So if I surround it, oh, I still have that rectangle. I gotta go back and get. Oops. Get. I wonder why I can't get no fill now. On black. You gotta get more. Thank you.
Custom colors.
Huh. Oh, well. So,
Custom colors, black.
all right. So I know I can do it with this, because it happens to
Right
be
side. Dark.
But it's almost a little confusing when that's not a different color, right? Line color. There. Okay. So if you couldn't figure out how to get that area, because it's tilted, you would surround it. And my red square, what's the area then?
Area of the square is, I don't know, if the wood square is
is 16, right? And what's the area of this triangle?
One,
Let him do it. So 1 by 3. 1 times 3 is 3. 1.5, right? So all of these are 1.5, right? So all together then, I'm going to do 16 take away 6, which is 6, right? So the area is 10. Did everybody get that?
No, yeah, that was my original answer.
Okay. Do we get that?
Yes.
So then I need to get rid of this stuff here for a minute. You know the area is 10. Let's get rid of this here. So that means there has to be some number times itself that gives you 10. Does anybody know what that would be? Yeah, Evan?
I don't know how you figure that out.
Exactly.
Somewhere between 2 and 2.
That's the new piece today. We could say it's the square root of 10. Watch. So go back to this. It's easy to see that here, right? Like on this problem up here, it's easy, right? To say, you know the square root of 36 is 6, right? You feel good about that because you know 6 times 6 is 36, right? And you feel pretty good about this. 2 times 2 is 4. But this is weird because you're not familiar with that, right? So that's actually the number. So look at this. If I take my calculator and I do the square root of 10, so I say 10 square root. It's not a rational number. But if I times it by the square root of 10, see how it says the square root of 10 times the square root of 10? What's my answer going to be? 100. What is it, Evan? 10. You guys see that? Some of you were talking. So, watch. The square root of 10 times the square root of 10 equals 10. I could do it with the numbers that you're more comfortable with. The square root of 36 times the square root of 36 is 36. So the way, what you guys have to see is that when you see the square root of a number times the same number, you only get the inside. Yes. Does that make sense? But you saw in the calculator it was about 3 something, wasn't it? And doesn't that make sense? Because if it was 3, it'd be an area of 9. If it was 4, it'd be an area of 16. It's a lot closer to 9, right? So when we looked at the square root of 10, it was like 3.1 something, right?
3.167 something.
Right. And so that's the length of the side. So if I wanted to surround this rectangle just to figure out the area, it would help me figure out the side length. So what's the area of the red square? 4. The black square, the black square is 2, right?
Yeah.
So if we get rid of the, if we get rid of the square, and zoom in because that's pretty small, and I want to figure out the side length right here, it has to be what number times itself gives me a value of 2.
Or 1.4. All right.
How do you write it? It's the square root of 2. Because, remember, when we look at the calculator, the square root of 2 is about 1.4. Good job on that. Okay. Times the square root of 2. See how it says square root of 2 times square root of 2 up there? What's the square root of 2 times the square root of 2? 2. Okay? It's a little weird because it's really,
I can see it.
it's kind of like, it's a new symbol. New symbols are usually a little uncomfortable. So go to the third area.
Wait, question.
That's okay. I can, we can, you know, extend it, right?
Be strong.
Right, so it was on the next side. Can you tell it should have been?
Yeah.
Right? So, you would surround this still, right? And be like right here. Okay, and let's make that yellow. Okay, so the area of that turned out to be the yellow. What was the yellow, Kyle?
Oh wait, no. I was asking a question.
Oh, what's your question?
So I heard that like that little the area, you write down what number you want to square it by. So you like to do cube root or like 10 itself or 10.
Right. So, you mean you would say the side squared is,
Can I show that like can I come up?
yeah, let's put a new page in there so we can see what you're talking about.
Because I heard that
Like do it with, say, this one.
well like oh no, this is not like square.
Oh.
It's like if you want it to be cube, I heard that be cube like this.
Oh, yeah. So next year, you guys will talk about cube roots. And it's an example of a cube root is instead of, like the square root of 16 is you need the same number twice to equal 16. So it's 4, because 4 times 4 equals 16. The square root of 8 is, the cube root of 8 is 2 because you need the same number 3 times. Oops. 2 times 2 is 8. So that's
And
true.
you could do like
Fourth roots and fifth roots.
and a 4.
Yeah. But we are gonna get there later, but you're right. We don't wanna get too, like, ahead of ourselves. So back to this problem here, the yellow square. Anybody get that? Everybody figured that area out? What'd you get, Daisy?
I got 13.
13? The area, oh, I see. The area of the yellow square, though.
Oh, the yellow square. I got 49.
49, right? And then this was 6?
Yeah.
Is that what you had? So
Yeah.
take away 24,
Equals 25. It's really
so
Oh.
25, right?
Yeah.
So this happens to be
5.
5. It's actually 5. It can be an integer number. It's not always an integer number. And if you don't believe that, you could always bring the ruler in, right? So if I had a centimeter ruler, I gotta calibrate it to match the grid though. So let's bring that down here. Right, this is supposed to be centimeter, or, so centimeter grid paper. Let's do that. So these dots should be a centimeter apart.
They aren't on our paper.
Well, a unit, can we say a unit apart? But on my board, my unit's gonna be a centimeter because I have that grid, right? So your 1 unit would work like mine, so now when I rotate this and put it over here, I should be able to measure a side, and it's 5. There's a little tiny bit of an error here, just because of the thickness of the line. So it is 5. Does that make sense? So when you don't, if we zoom out now, when you can't, so this is called 25 is a perfect square, because when you take the square root, it's an integer. So the integer length, I'm going to get rid of these 6's because it looks a little confusing. We don't really need this anymore. A perfect square is one that you already are comfortable with, one that just is an integer. So if we add in a page and talk about what a perfect square is, you should know your perfect squares at least to 144 right now. So like the perfect squares are 1, because 1 times 1 is 1. The next one comes from 2 times 2. So the perfect square is 4. So these are the perfect squares, and this is like the dimensions of the square. So this would be 9. The next one, 16.
32.
No, not
Wait,
three.
no.
Because this 16 came from 4 by 4, right? This came from 3 by 3.
So 25,
25,
36,
36,
49.
49,
Yeah, 64.
right? 8 squared, right? 9 squared, 10 squared,
100,
11 squared, and 12 squared.
104.
Okay, and there's an infinite number of these, right? Now think about some of the areas we've got on this page, like the square root of 10. Well, there's no way to get the square root of 10. All we know is that the square root of 10 has to be bigger than the square root of 9 and smaller than the square root of 16. You guys know that? Because like the area of a square, when a square has an area of 10, it has a bigger area than a square that has an area of 9, and a smaller area than a square that has an area of 16. So somebody said, how do you get that when you don't have a calculator? You can actually get a really good approximation for this. Right now you should know that it's 3 something. Okay, and that part we're going to talk about later. Okay, it's 3 point something. Okay, it's more than 3 but less than 4, and it's much closer to 3, isn't it? So it's going to be less than 3.5 probably, right? So how are we doing so far? Because I'm going to do something kind of that looks sort of totally different in a minute. I'm going to teach you how to approximate this. You ready for that?
Yeah.
Okay, so we need to go to another grid paper, but I'm just going to bring in some grid page from the smart board. So I want a full page here. Okay. For, yeah, different applications. Okay, so if I wanted to, this is a little weird, so you gotta give me like 3 tries before you ask questions, okay? And the bigger the square, the better the estimate is. So first of all, what you have to understand is once you use a square root symbol, like the square root of 10, the exact number is the square root of 10. Once you put a decimal here, you're just doing an approximation, like we did on the calculator. So the calculator, when I type in that square root of 10, that's an approximation. Even though there's all those digits, it goes on forever without a pattern. So we call it an irrational number. The best we could do is write down the square root of 10 like I did in red. That's the most exact answer. But it's not a very understandable answer. So we like to have approximations. So we're going to say this is about 3.2. Can you guys see that? But since it's not exactly 3.2, you might put a dot there, or you might see this. Square root of 10 is about 3.2. It's not exactly. Okay? So where it comes from is looking at your square below it, square of 9. Okay? And then, so then, this is kind of, this is where it gets a little unusual. So you guys give me a few tries. So if I look at this here, and I've got a perfect square of 9, but I want the square root of 10. So I'm 1 square on the way to the next square root. Okay? You see that? So I had that one. And then I need, and I'm going to make these kind of faded. I need all of these, though, to really get to the next square root. I would need a bunch of these. How many more would I need to get to the next square
Well,
shape?
you need that, those 3 you already have, plus 4.
Can you guys see? I'm gonna build and tell me when I'm done.
Done.
You guys see that? I've made the next square. So my way to approximate, and this is actually surprisingly accurate, especially as the numbers get bigger, is that you know it's between the square root of 9 and the square root of 16. Okay? So we say it's 3 something, and we're going to give a fraction. It's 3 and 1 square out of the 1, 2, 3, 4, 5, 6, 7 that I need.
Whoa.
It's about 3 and a 7. Now, it's going to be decent, not great, but as I get to bigger squares, it's pretty good. So watch. What's 1 divided by 7? 1.14. So my approximation says it's 3.14, and the calculator, when I actually type it in, was 3.2. Okay, so watch.
It's about a fifth.
Yeah, so not bad, right?
It's actually 3.16.
So if I made a bigger square, if I did it, well, we probably want to keep this so we can look back in it. So if I wanted to approximate, say, the square root of 32, okay? Then if I want to do the square root of 32, I know that the square root of 32 falls between the square root of 2 perfect squares. What's the perfect square right below it? 25. And right above it, 36. So right away, we know that it's 5 something, right? So if I took a square and I made the smaller one a 5 by 5, okay, I have the square root of 32, so that's 26. You know, there's 25 squares inside, right? So 26, 27, 28, 29, 30, 31, 32. So I'm 1, 2, 3, 4, 5, 6, 7 squares on the way. But how many more do I need? Tell me when I'm done. So visually, you guys all know, right? When you see it, you know I'm to the next square, right? So when we count, I was 1, 2, 3, 4, 5, 6, 7 squares out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 7 squares out of 11. So let's see how accurate I am. So 7 divided by 11 is 0.636363, okay? So I'm saying this is about 5 and 7/11ths, which is 5.6363, right? Repeat. If I just put in the square root of 32, 5.65. Pretty close. Really close. So can you do this without drawing a picture?
Yeah.
You can, if you understand what's going on. So did you see, like, I had, to get from 25 to 32, I had to add in how many little squares? 7, right?
Oh, and then you
7, 32 take away 7.
Oh.
But to get from 25 to 36, I needed 11. So even though the picture kind of gives a meaning, like where was she getting those numbers? Of course you're not going to pull out your 98 chips from your pocket to figure out the square root of 98, right? I mean, you might, but chances are you're not. Okay? So if I wanted to figure out the square root of 98, I'm going to understand the process. I know the square root of 98 is between 81 and 100. You guys see where those numbers are coming from?
Yeah, because
Because those are the perfect squares right above and below. So this is 9 and 10, right? So this is 9 something. Well,
17.
yeah, I have to add 17 squares
17.
to get to there, right?
17. Yeah.
But to get all the way to 100, I have to add 19 squares. So this is about, not exactly, remember this is the exact answer. This is about 9 and 17 19ths. So if I want to do the square root of 98, first of all, let's really get a calculator approximation. They say it's 9.899. That's the calculator. By the calculator, it's 9.899. It goes on, right? But by the screw likes geometry method, okay, it's 917 divided by 19. 9.89. Accurate to 2 decimal places. It's going to be really accurate the bigger the number.
But does it ever get perfect?
No, it's never, not even the calculator is not perfect, right? The only way to write the perfect answer is, this is the exact answer. But it's not very meaningful. It's like pi, it's an irrational number. So it's more meaningful for us if we could kind of say what it's approximate to. So like I can do square roots pretty accurate in my head, you know, if I need to. Yeah, Evan.
But wouldn't it would be the exact perfect same in infinity?
There is, the longer, like if you did this for every day for the rest of your life, you could probably get as accurate as, you know, probably 50 decimals or whatever if you wanted to figure it out. But that would be like kind of a, well, not my choice how I would spend my days,
But
but
I mean, like, what if the actual thing, infinity?
infinity is a concept.
I know. But wouldn't it be perfect at infinity theoretically?
Yes.
In theory, you can get as close, as accurate as you have time for. You could spend a lot of time doing this, but I would think you guys might have some other things that you'd like to do. That being said, if you picked a bigger, should we do a bigger number?
Yeah.
Like, let's do,
Do 1,000,000.
okay, that's pretty big. How
A
about,
million.
like,
101.
let's take two perfect
10,000.
squares we know. Like, 25 squared is 625. Okay, watch. Just so you guys know I'm not just making these things up, right? So 25 times 25 is 625. So 26 times 26 is 676, okay? So what if I did the square root of 650, okay? Does that make sense? So that means it's between the square root of 625 and the square root of 676. So this is 25, and this is 26. So I know this is, oops, equals, it's approximately equal to 25 something, right? So how far apart, how many squares would I have to add? I need to add on 25 squares. And how many squares do I need to add to get all the way to there?
40. No. 51.
51.
Yeah.
Yes. So 25 divided by 51 is 0.49019. Let's write it down. 490,196. 0.490196. So about 25.490196. Okay? So now I'm going to take the square root of 650. 0.49, still only went 2 decimal places, but still the 2 decimal places is pretty good. So I'm guessing you'd have to go a long, long time to get lots of those decimals like the rest of your life. But we really don't usually care. If we want exact, we just use the square root symbol. Okay, so no homework. We're going to work on this stuff tomorrow. Have a good day, guys.